Okay, we're going to continue our little discussion of quadratics, but first I have to do a shout out to Jack Berge and the Burgermeister family. How you doing, folks? And I'd just like to remind Mr. Burgermeister about the 50-meter rule, that there's no water runners or um, uh, runners or anything like that allowed within the 50 zone when the kick out is occurring. Okay, we just got that right. Now we're going to go on to quadratics, and we're going to talk about the quadratic formula, because I know that's a favourite of Laney West, who loves the quadratic formula, was saying to me, Mr. Nielsen, when are you going to do something on the quadratic formula? So I thought I'll do something. So quadratic formula. And quadratic formula, as you'll remember, was one of our strategies for finding the zeros of a quadratic equation. And first of all, you've got to have the equation in the general form. When it looks like that, and A, B, and C are all real numbers, A not equal to 0, and as we know, these numbers, we call them coefficients. So A is the coefficient of x squared, B is the coefficient of x, and C is the constant or the coefficient of x to the power naught. Okay, so what is the quadratic formula? Well, I'm glad you asked, because otherwise it would have been pretty silly for me to do this video. So the quadratic formula is when you have that general formula, x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 lots of a. And this little bit in here has a special name. We call it delta. That equals the discriminant. The discriminant equals b squared minus 4ac, and that has a very important role to play, or whatever, because if we work that out and it turns out that that value is negative, it implies no zeros for our parabola. In other words, it's either a parabola like that or a parabola like that, something like that. Either it's a smiley face above the x-axis, because we know that's the y and that's the x-axis, or it's a frowny face below the x-axis. Okay. Just getting my pen going. Okay, so let's give us some examples to see what we're talking about. Let's take y equals 3x squared plus 4x minus 2. Okay, so we want to make that equal to 0 to find our x-intercepts, or our zeros, or our roots, whatever we like to call them. So x equals, now we could try and factorize that. I'm not sure if it will factorize, but if we can't factorize it, then we use the quadratic formula. Now first we're going to note our coefficients. Our coefficient of x squared was a, is 3. Our b, our coefficient of x is 4, and c equals minus 2. Okay, so x therefore is minus b, which is minus 4, plus or minus the square root of b squared, which is 16, minus 4, times a, which is 3, times c, which is minus 2. Minus 2, it's all under the square root, divided by 2 lots of a, which is 6. So, therefore, x equals minus 4 plus, sorry, I'll get rid of that, that's no good. Plus or minus the square root. Now, 16, we've got a minus here and a minus there, so that minus times a minus gives a positive. So we've actually got 16. Now this is 4 times 3, which is 12, times 2 is 24. 16 plus 24 is the square root of 40. and that's divided by 6. Okay, so I'll just, so therefore we get 2 roots out of this. Our first root, we call it x1, is minus 4 plus the square root of 40 over 6. And the other one, we could call it x2, equals minus 4 minus root 40 all over 6. And of course we could probably simplify those thirds, and that might come out to something a bit easier, but basically that's how it's going to look. So this one, that's got a third in here. I can't get rid of that third, so it's just going to look like that. But that's basically how we use that formula. Okay, let's get rid of that. No, that's not what I want. That's the one I want. So let's have a look at another one. I'm just making these up as I go. So how about I'm going to do x squared plus 2x plus 9. Okay? And I'm just going to ask the question, does this have any roots at all? Now what I could do is use the quadratic formula, but I'm just going to use that little part called the discriminant. Okay, that's a 2 there, sorry. And first let's work out our coefficients. A is the coefficient of x squared, and there's a 1 there, so we'll call that a 1. B is 2, and C is 9. We should be able to start to work those out. So let's work out b squared minus 4ac. So b squared is 2 squared minus 4, a is 1, and c is 9. So this equals 4 minus 36, which equals minus 32. Now that is less than 0, and this implies no roots at all. So there's no zeros. So this, it's a smiley face parabola. Here's our y and here's our x. So it must be one of these that sits above the x-axis. Okay, we'll just try one more before we finish this. And I'm going to do y equals minus 2x squared plus 3x minus 5. Just going to fix that up a bit. Get rid of that. Makes it a bit better. That's a 2 there. Okay. Now, of course, we could write this in any order we want. You know, I could have written this like minus 5 minus 2x squared plus 3x. It doesn't matter. I don't have to write them with the, you know, like with x squared there. I can write it in any form I want. But in the same case, work out our A, our B, our C. And so A equals minus 2. Okay. B equals 3. And C equals minus 5. So let's just work out what the roots are of this and see if they'll get any real roots at all. So x equals minus b, which is minus 3, plus or minus the square root of b squared, which is 9, because 3 squared equals 9, minus 4 times a. Now a is minus 2, times c, which is minus 5. And that's all over 2a, which is minus 4. Okay? So this equals minus 3 plus or minus the square root. And that's all over minus 4. Now what have we got in here? We've got 9. Now this minus 4 times minus 2 is 8, because the negative times a negative is an 8. Sorry, a positive. But the positive times a negative gives a negative again. So this is actually 9 take 40. 4 times 2 is 8. 8 times 5 is 40. So this is minus 31. So this number here, our discriminant, is negative. So once again, no roots. Okay, I hope you followed that. We'll have a few more. We'll have to do completing the square and a few other things. So Good night to the Bergie family, and just a shout out to the Lockie Lucas and your family. Good night, Lockie.